Question number 10, I think so. We have done this. This is the given vector. With help of this given vector, first you have to find, can you hear me, students?
Yes, sir.
Yes.
Yes, sir.
Right. So with help of given vector, first you have to find unit vector. Unit vector means a cap. A cap is equal to vector A by magnitude of A. That is 5i minus j plus 2k by magnitude of A means root over 5 square plus minus 1 square plus 2 square. So this is equal to 5i minus j plus 2k all divided by root over 25 plus 1, 30, 30, sorry, 25, 26 plus totally 30. Root 30 we got. So just this is unit vector, but they're asking about like find a vector in the direction of with 8. Like we need to find in vector B. Okay, I want to find vector B here. Vector B, this is equal to its magnitude. Magnitude means magnitude of B is clearly, they have given 8 in the question, magnitude already given, but in this direction means into A cap. Okay, we have to find a new vector. Already they have given, this is a vector A. Vector A is given. So in the same direction, in the direction of vector A, I want to find vector B whose magnitude is 8. Magnitude is 8 units. For that, what shall we do? This is vector B. Vector A, in the direction of vector A, we need to find the vector B whose magnitude is 8 units. Like for that, first we have to find a unit vector of the given vector A. I found the unit vector of given vector A. So after that, so vector B is equal to 8 times. Magnitude of B is clearly 8 units they have given. 8 into A cap. Nothing but 5i minus j plus 2k by square root of 30. This is the required answer. You may multiply here. So 8 into 5, 40, 40 by root 30 into I cap minus 8 by root 30 into j cap plus 16 by root 30 into k cap. This is vector B. Got it? Students, is it clear? Like that. So this is the required vector whose magnitude is 8 units in the direction of given vector A. A simple question. For given vector, you have to find the unit vector, after that 8 into that unit vector. And coming to the next question, question number 11. Show that the given vectors are collinear. First, let us consider the first vector is vector A, second vector is vector B. Can you tell me what is the vector A? First vector is vector A. So vector A is equal to, yes twins, 2i minus 3j plus 4k. Vector B is minus 4i plus 6j minus 8k. Got it? Right. So now I want to prove that these are the collinear. So I want to do one thing. I told you very clearly the vector A comma B are said to be collinear, which implies B vector is equal to lambda times of A vector, or A vector is equal to lambda times of B vector. Any one of the way we can express. I already somewhere I have written that collinear. Okay, A is equal to lambda times of B vector. See here, clearly I have written here, B is equal to, I express 10 into A vector, then A comma B are collinear. In the same way, Is there any possibility to write the B vector is equal to some lambda times of into A vector? Yes or no? B vector is equal to minus 4i plus 6j minus 8k. If I take here minus 2 is common. When I take minus 2 is common, then is it 3j plus 4k? Is it same? Like what about this B vector is equal to minus 2 times of, what about this value? This is the given vector A. So minus 2 times of A vector. So this is in the form of B vector is equal to lambda times of A vector. Here lambda is equal to minus 2 is clearly real number. I told you very clearly lambda is any real number, any real number. It may be positive, it may be negative, it may be fractions, it may be decimals, but it must be a real number. So one vector we can express the lambda times of other vector, then A comma B are collinear. Right, we proved here. Right, we show that the two vectors collinear. Next, coming to the question number 12. 12 is find the direction cosines of the vector. It's very easy. Like I'm taking the given vector. If you're having any doubts, you can ask. Given a vector, I'm taking like a vector. A vector is equal to I plus 2j plus 3k. I plus 2j plus 3k. See student, I want to comparing this vector with a1i plus b1j plus c1k. Got it? I want to compare. Then here, with help of this, here actually direction cosines. Direction cosines can be given by L, M, N. LMN. LMN are the direction cosines always. Okay, that is equal to that we know that cos alpha, cos beta, and cos gamma. So the direction cosines also can be written as cos alpha, cos beta. Cosines, cosine means cos. Okay, so I want to find this LMN. C student, here A1, B1, C1 is there. What is A1, B1, C1? Directly here, A1, B1, C1 are called direction ratios. Direction ratios. Always A1, comma B1, comma C1. But whereas direction cosines. Directly. So in given vector, what are the direction ratios here? 1, 2, 3. 1, 2, 3. What are the direction ratios of this vector? 1, 2, minus 1. What are the direction ratios of this vector? Minus 1, 1, 1. What are the direction ratios of this? 1, 2, 3. Okay. What is the direction ratios of this? 2, minus 3, 4. What is the direction ratios? Direction ratios directly the scalar components. But direction cosines? The direction cosines again the depending on direction ratios. Okay. Direction ratios is nothing but A1. Here direction ratios are A1, B1, C1. So here A1, this is B1, this is C1. But the direction ratios is A1 by magnitude of given vector, B1 by magnitude of given vector, C1 by magnitude of given vector. So first what shall we do? First with help of given vector we have to find a magnitude. Magnitude nothing but we know that A1 square plus B1 square plus C1 square. Got it now with help of this. What is A value? 1. 1 square plus 2 square plus 3 square. Got it? So finally this is 1 plus 4 plus 9, that is 14. So magnitude of A, we got it like 14, and A1 value is 1. Yes or no? When I comparing these two, A1 is equal to 1, B1 is equal to 2, and C1 is equal to 3. Substitute all values here. 1 by root 14, 2 by root 14, 3 by root 14. These are the direction cosines. Okay, given directly, given coefficient of I, J, K are like scalar components or direction ratios directly. but these are direction cosines, the direction cosines. Okay, right, these are the direction cosines. Got it? Scalar component by magnitude of given vector, scalar component by magnitude of given vector. Okay, like that. So these are the scalar component. Any doubts, friends?
No, sir.
Right, simple to find. But this direction ratios, direction cosines can play very important role in 3D. Right, coming to the next question. Question number 13. Find the direction cosines of the vectors of the vector joining these 2 points, directed from A to B. First, what will we do? What is the position vector of the point A? Position vector
One
OA.
I plus 2j minus 3k.
Good. What is the position vector of B here?
Minus I minus 2j plus k.
That's it. So first you have to write the position vector of the given 2 points. Okay, the position vectors of given point is OA. OA is equal to, what is OA? I 2j minus 3k. I plus 2j minus 3k. And OB vector is minus I minus 2j plus k. Right, but here we have to find the direction cosines of the vector A to B, A to B, simple strings. See, in previous question directly they have given vector, so that we found very easily uh, the direction cosines. But here vector is given, no, vector is not given, but they have given the 2 points, and we need to, with help of these 2 points, first we have to find the vector from A to B, A to B. Okay, from A to B. At A, the position vector can be written as OA vector. At the point B, the position vector can be written as OB vector. But here we require to find AB vector from A to B. That is AB vector is equal to, it can be written as OB vector minus OA vector. Always this is a formula. AB vector is equal to OB position vector of the end point minus position vector of the starting point. Like we know that OB means minus I minus 2j plus k, minus of I plus 2j minus 3k. Got it? Right, this is equal to what? Here minus I minus 2I minus 2j minus 2j minus 4j and plus 4k. Got it? Right, this is the vector AB. I am taking this vector as A vector. Vector like same procedure. And previously what I have done, I comparing with A1, B1, C1. Now here also given vector comparing with A1I plus B1J plus C. Position of any vector, just take any point is given, that point into I, J, K, that's all. Okay, when I compare here, what is A1? First, before that, first you should find magnitude of A. Magnitude of A, square root of minus 2 square plus minus 4 square plus 4 square. That is nothing but 4 plus 16 plus 16. That is equal to what, students? Is it correct? Magnitude means it is a length from one point to other point. It can't be negative. The square root of 36, it should not take plus or minus, just take plus. because length cannot be negative, right? Okay, fine. We got magnitude. Then very simple. Now, when you comparing here, we got A1, B1, C1. Then L is equal to A1 by magnitude of A, and M is equal to B1 by magnitude of A vector, and N is equal to C1 by magnitude of A vector. Just substitute here. Magnitude of A is 6, and A1 is -2, B1 is -4, C1 is 4. You can substitute, you'll get the direction cosines. So when they have given 2 points, with help of 2 points, first you have to find the vector from A to B, one point or other point, with help of the position vector. Now, next question. Coming to the next question, uh, 14th one. Show that the vector I plus j plus k equally inclined to the ox, oy, oz. See here, for example, you can take a room, like in a classroom. Classroom is belongs to three dimension. Three dimension. You can take a corner. I told you, like take a corner. Corner point is the like origin. Any corner point. Like let us say this is a 12C classroom. Okay, every classroom consists of three dimensional. Okay, like this I'm taking as x-axis, y-axis, and z-axis. Okay, if I take any point in the space, any point in the classroom, like other than on xy plane, yz plane, zx plane, like that, if I choose one of the corner is as origin, you can take the opposite corner as a point. Okay, if you join this origin to that opposite corner as a line, so that line segment having making some angle with x-axis, some angle with y-axis, some angle with z-axis. Okay, like here I'm taking, this is the origin, one of the corner in classroom, and I'm going to take PB, any point P of x comma y comma z is any point in the space. If I join these two, I join these 2 points, like we'll get a OP vector. Like initial point is O, terminal point is P. Okay, this line can make some angle with x-axis. It can make an angle alpha, and with y-axis it may be like beta. With respect to z-axis, the angle it will be a gamma. The line can make, see, in in plane, like in the board, like this whiteboard, we cannot take the three-dimensional properly, but okay, like that, just you can assume that origin is one corner, opposite corner as a point, like with respect to x-axis alpha, with respect to y-axis beta, and with respect to z-axis it is gamma. Okay, right. Okay, otherwise you can take this, you can see here, this is like x-axis, this is z-axis, this is y-axis. If I take this is line segment, see, this is x-axis, this is angle between these two axes 90, x-axis, y-axis, z-axis. If I take any line like this, see, with respect to x-axis here, it can make some angle. With respect to y-axis, it can make some angle. With respect to z-axis, it can make some angle. That is alpha, beta, gamma. This alpha, beta, gamma are called direction angles. The name of alpha, beta, gamma are called direction angle. Alpha, beta, gamma are called direction angle. Okay, same cos alpha, cos beta, cos gamma. See here, alpha, beta, gamma are angles. What are the angles? Direction angles. Here cos, cos, cos. Cos nothing but cosines. Generally we can call cosines. Cosines we cannot write simply, we write COS. Actually what is cosine? Okay. So then alpha, beta, gamma are direction angle. Cos alpha, cos beta are called direction cosines. cosines. That is the reason we can say that cos alpha, cos beta, cos gamma are called direction cosines. Fine. Here in this question, coming to the question, show that the vectors equal the given vector. Like if I take this, like vector is the point is when the point becomes 1, 1, 1, then this vector OP vector, I'm taking here itself A vector, is given by I plus J plus K. Am I right? 1, 1, 1, nothing but we will get the vector is I plus J plus K only. Okay, this is a line. This is a vector. Vector can make an angle alpha, beta, gamma. Now, so whenever you want to show that the vector having equal incline, nothing but what shall we do here? We can prove that alpha is equal to beta is equal to gamma. When alpha is equal to beta is equal to gamma, then we can say that the vector incline the equal angle to all the three axes. Okay, right. Now I'm taking the given vector as vector A, I plus J plus I plus J plus K. Got it? Now, any vector they have given this kind of questions they are asking. Yes, here we have to find cos alpha, cos beta, cos. Just now already we have done this. First you have to find direction cosines. That first you have to comparing with A1, B1J plus C1K as it is already just now we have done. What we have done? Same like comparing with A1, B1, C1. After that you have to find magnitude, then find cos alpha, cos beta, cos gamma. That's it. Here also we will do the same. A1 is equal to 1, B1 is equal to 1, C1 is equal to 1. Next, magnitude of vector A is what? Root over 1 square plus 1 square plus 1 square, that is root 3. Now next what? Cos alpha, cos beta, cos gamma. That's all. Okay. Cos alpha is equal to what, students? Cos alpha is? What is cos alpha? A1 by?
1 by root 3.
Right. First you have to write what is cos alpha. A1 by magnitude of E. That is A1. A1 is 1. 1 by root 3. And which implies alpha is equal to cos inverse of 1 by root 3. Okay, I found one of the angle like alpha. And in the same way, cos beta is equal to A2 by magnitude of A. So that is 1 by same root 3, which implies beta is equal to cos inverse of 1 by root 3. In the same way, what is the gamma? We are going to get same cos inverse of 1 by root 3. So therefore, what shall we conclude here? Therefore, here alpha is equal to beta is equal to gamma. Hence, the vector is equally inclined to the axis Ox, Oy, Oz. That's it. So what I have done, students? They are asking equally inclined means we have to find cos alpha, cos beta, cos gamma. What is cos alpha, cos beta, cos gamma? These are direction cosines. So first we have to find the direction cosines. Got it? First we have to find the direction cosines. For finding the direction cosines here, for finding the direction cosine, now comparing with A1, B1, C1. After getting that, you can find the magnitude of given vector, then A1 by magnitude of A, B1 by magnitude of C1 by magnitude of A. That will give cos alpha, cos beta, cos gamma. Right, coming to the next question. Yeah, see here, question number 15. Find the position vector of the R which divide the line segment 2 points P and Q whose position vectors are okay P and Q. P position vector, that is nothing but this is OP vector. Q position vector means this is OQ vector. Here OP vector is given, OQ vector is given. They are asking to find position vector of R. R nothing but we have to find OR. OR. Right? This is internally, externally. It's very simple formula, students. So this ratio you have to take m is to n. Now, can you tell me what is the section formula in geometry? Section formula is geometry. Generally, mx2 plus nx1 by m plus n. Am I right? Am I right, students? Yeah. Here, if I take this OP vector as vector A, OQ vector as vector B, then internally nothing but plus, externally nothing but minus. That already we have seen. Here also simply the same way, m into b vector plus n into a vector by m plus n. In geometry, mx2 nx1 by m plus 1, comma my2 plus ny1 by m plus n. We are taking like two ways. But in vectors, it's not like that. Just simply mb vector plus na vector by m plus n. This is internally. Coming to the externally, mb vector minus na vector by m minus n. These are the formulas. That's it, simple. Okay, to remember, yeah, I'll do one problem, you can do remaining. First step, I'm going to take here, this is P, this is Q. What is the ratio they have given? 2 is to 1. 2 is to 1 means I want to take like this. This is 2, from here to here 2, this is 1. But there is a point R, this, yeah, position vector of the P nothing but, it's very simple, students. Now whenever they ask the position vector, first you have to take the origin, like 0 0 0. Now the position vector of the P nothing but origin to the point P. This OP will give the position vector of the point O to P. This vector already they have given. What about this vector, Amma? This vector is I plus 2j minus k. This vector is I plus 2j minus k. Okay, this vector I am going to take as A vector. A vector. So nothing but what? This vector is A vector. This is also can be written as OP vector. OP is equal to A vector. The position vector of the Q nothing but from O to Q. This is called position vector in this direction. Starting point is origin, ending point is Q. This vector already is given in the question, minus I plus j plus k. Minus I plus j plus k. This vector is given by, this is also, this can be represented with OQ vector. I am taking this vector as vector B. Vector B. A vector I am taking as OP. B vector I am taking as OQ. Then I want to find the position vector of the point R. This is the question. This is the question. Look at here. Find the position vector of the point R which divides the line segment joining 2 points whose position vectors in the ratio 2 is to 1. Everything I have taken. Now we have to find this vector OR. Let us take this is C vector. C vector is equal to OR vector. So OP is given, OQ is given, and we need to find OR. For that, this point R can divide the given 2 points in the ratio 2 is to 1. Explaining with help of these figures, right? Okay, like OP, OQ, OR. So it is not at all difficult. So here C vector. This, what about this point, Amma? Is it internally or external point? Between PQ or outside of PQ here, the point or internal. So this is internal. The vector internally can be is given by vector C is equal to vector C nothing but OR is equal to, it can be written as M B vector plus N A vector by M plus N. That's it. Like same like geometry, but here in the sense we can find the answer in terms of vectors. Okay, we know everything. This is M value is 2, N value is 1 because the given ratio M is to N is 2 is to 1. So why don't we substitute here? So vector C is equal to M B. M means 2 is to B vector is minus I plus J plus K. Plus N means N value is 1. 1 into A vector is I plus 2J minus K. Yes, here. This is the vector. This is vector A. This is vector B. With help of, this is ratio. With help of these 3 points, by M plus N, 2 plus 1. 2 plus 1. Just simplify this, minus 2I plus I minus I plus 2J plus 2J plus 4J. 2 into K, 2K minus K by 3. So this is the position vector of R. C vector means OR is equal to, it's better you can write it separately, minus 1 by 3 into I cap plus 4 by 3 into J cap plus 1 by 3 into K cap. See students, in exam you try to write always like I cap, J cap, K cap or G cap. You should not write simply I, J, K. Actually that is wrong. In exam you must be write cap or else simply arrow mark, I vector, J vector, K vector. So this is the required position vector of the point capital R, okay, between P and Q in the ratio 2 is to 1. This is the required vector. Simple. Is it difficult? Say only one formula, MB plus NA by M plus N. In the same way, you can try to do the externally. What is the external formula? Instead of plus, you can take minus. That's all. Instead of plus, you can take minus. Next, coming to 16th one. 16th one, I'm giving as homework. Homework. When they have given two vectors, vector A and vector B, see it. Vector A and vector B, they are asking about the vector of midpoint. Midpoint means any vector, midpoint means when they have given two vectors, they want to ask the midpoint of the vector is given by A plus B by 2. What is the formula in x1 plus x2 by 2, comma y1 plus y2 by 2 in the same way? Here, fine. Here, what about the two vectors? What about the vector A? Vector A is position vector of the point P. OP vector I am taking as vector A, that is 2I plus 3J plus 4K. First we have to take the position vector of the point P, and this vector I am taking as B, that is OQ vector is equal to 4I plus J minus 2K. Yeah, here we know that A vector and B vector. Then the midpoint I am taking as R, that OR vector is equal to, same, OR vector is equal to A vector plus B vector by 2. That's all. Here A vector is 2I, 3J, 4K and B vector is 4I, J minus 2K. We know A vector, B vector. Why don't we add and dividing with 2? That's it. You'll get the midpoint. Midpoint means same sum of the vector by 2. That's it. So coming to the question number 17. Question number 17, look at the students here. Show that the points A, B, C with the position vector A, B, C. Position vectors are given respectively. Form the vertices of right angle triangle. Vertices of right angle triangle. Nothing but see here. This is important question. Most of the students, they might be do some mistakes in this question. It is but very easy question. Look at here. How can you say whether it is easy or difficult? In three-dimensional, I'm taking x-axis, y-axis, and z-axis. This is the z-axis. This is about z-axis. X, Y, Z. Let us assume like this. X, Y, Z. Some in textbook they have given this is x-axis, this is y-axis, this is z-axis. They have considered like that. That's your wish. You may take x, y, z, or else x, y, z. That's up to you. You may take any way. I'm taking this is x-axis, and this is y-axis, this is z-axis, this is origin. So what about here? When you observe the question here, they have given 3 position vector. Okay, position vector means I'm going to take 3 points. Like this point is one point is A, one point is some B here, some point C here, some point C will be here. Okay, now position vector. Position vector means I told you when the word you heard that position vector means initial point must be origin. This is the point I'm taking as A. This is the point A. Let us consider this is B, this is C. Okay, here position vector becomes, in that case, the position vector, first I'll join all these 3 points. This is B, OB vector, and this is OC vector. 3 vectors they have given. In that, 3 vectors they have given. In that, I am taking the OA vector. I am vectoring as vector A, B vector as vector B, C vector as vector C. Okay, let us assume like that. See, what is the question here? These 3 position vectors, A vector, B vector, C vector, already given in the question. So these 3 vectors are the vertices of right angle triangle. So A, B, C, and whose position? A, sorry, A, B, C. This is A, this is B, this is C, are the position vector of the vector A, B, C. Right, this will form a right angle means when I join these values. Yes, students. When I join them, these 3 points, see here, it will form a right angle. Just they are asking to show that these 3 position vectors form right angle triangle. For that, what shall we do? For that, what shall we do? Very simple, students. This A vector is given, B vector is given, C vector is given. From that, you have to find AB vector and BC vector and CA vector. For finding OB, see here this vector A nothing but this is position vector of A means OA vector. A can be written as OA, B vector can be written as OB vector, C vector can be written as OC vector. Vector small a is equal to OA vector because A be the position vector of the point capital A. So small b vector be the position vector of the point capital B. So we can write like this. So with the help of this, first we have to find this AB vector and BC vector and CA vector. Is it difficult to find AB, BC and CA? No, never. So how can you find AB vector? AB vector is given by OB vector minus OA vector. This you know already. BC is OC vector minus OB vector. And CM is OA vector minus OC vector. Got it? Yeah, all of you do this and tell me what are the vectors somewhere. Yeah, what are the vectors? That is not, this is nothing but B vector minus A vector. This is nothing but C vector minus B vector. This is nothing but A vector minus C vector. Then can you tell me what is the vector AB that is I require? With help of this, AB vector is what, students? What is BC vector? What is CA vector? Fastly. Tell me AB, BC, CA. AB means B minus A. So here A vector is, I'm going to take right A vector, B vector, C vector here. A vector is here 3 minus 4 minus 4. Then B vector is 2 minus 1 1. 2 minus 1 1. C vector is 1 minus 3 5. 1 minus 3. C vector is equal to 1 minus 3 and 5. So now what about AB then with help of this? B minus A. B minus A, that is minus I plus 3J plus 5K. And BC, OB minus C minus B. C minus B means minus I minus 2J plus 4K. CA vector means A minus C. 2I minus J minus 9K. Fine. After getting this, okay, finally we got the vectors of AB, BC, CA. After getting this, if you want to check, whether this will form a right angle triangle or not, with help of Pythagoras theorem, So what shall we conclude here? Yes, students. This is A, this is B, this is C, or else this is C, this is B. Like AC square plus CB square is equal to AB square. Yes or no? Like that here, to do this, first we have to find the length. Okay, we got the vectors AB vector, BC vector, CA vector. With help of that, now I am going to find magnitude of AB vector, that is square root of minus 1 square plus 3 square plus 5 square is equal to what? 25, 9 plus 1, 10. This is 35. Then BC vectors. Already we got BC vector here, BC. Then magnitude is minus 1 square plus minus 2 square plus 4 square. That is nothing but 1 square is 1 plus 4 plus 16. How much? 21. The same as CA. Magnitude will give the length of the sides. Root over 2 square minus 1 square minus 9 square. Do we done any mistake here, students? Do I done any mistake? Here minus 5I is there. I have written plus I. The values becomes wrong. AB is going to be wrong. AB is correct only. Then BC becomes wrong because minus minus 5 minus 6 here. It will be minus 6. It is these two values will be changed. A minus C, that is plus K. Now here also it will be changed. This is clearly 6 square. Nothing but 1 plus 4, 5, 5 plus 36. This is 41. This is 1. So 2 square 4 plus 1, 5, 5 plus 1, 6. Now these are the length of the sides. Here we got this length is AB is AB is 35 more. So we should change that here. These 2 points you can change. This is B, this is C. No. This you have to change it. This is clearly BC. This is B, this is C, this is A. Now see here, AB length is root 35, this is root 41 and root 6. When I do this, like now, according to this, is there AB square plus AC square must be equal to BC square. Yes or no? AB square is 35 plus 6 is equal to 41. So LHS equal to RHS. So clearly the given 3 position vector form a right angle triangle. First, what I have done here, with help of given vectors. I found the sides of the right angle triangle. I found all the vectors like AB vector, BC vector, and CA vector. Then here you have to change the position vector here. Just not to see. After doing only, we know that here this is clearly what this is C, this is A. This is a vector A is equal to OA vector. Oh. Okay, students. This is OA remaining okay. This is OC vector. Finally, with help of that, I found the vectors sides of the triangle. Then after that, I found the length of the sides. Magnitude will give length of the sides. With help of Pythagoras theorem, it satisfies the Pythagoras theorem so that the given vector form it. It's very simple questions, right? Now, coming to the question number 19. Okay, A and B are two collinear vectors, then which of the following is incorrect? First, let us see 19, then we'll go for 18. So, B is equal to collinear vector. This is the definition of collinear vector. This is true. They are asking incorrect. Here, A is equal to plus or minus B. And also, collinear nothing but both the vectors having same direction but different magnitude. Is it true, students? I'm telling opposite direction. Same direction or opposite? Same direction. This is vector A. This is vector B. Both will be same direction but different magnitude. Is it collinear? No problem. It may be collinear, but it should be parallel. Must be the parallel. So what is the option is incorrect, students? Option B is incorrect. So here respective components of this is also incorrect. Option C, where the respective components are not proportional. Is it not proportional? Because collinear nothing but what? Parallel. Parallel nothing but what? If I take any two vector A1i, B1j plus C1k, this is A2i plus B2j plus C2k. Parallel nothing but then when two vectors are parallel means A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Got it? We can take like this. Okay. So what is the correct option they have given in book bag? Just look at. Yes, students. This is also not compulsory that it must be having collinear nothing but it must be having different magnitude. It may having same magnitude also we can say that collinear. So option D also wrong, option C is wrong. Like option B also it is not possible. Then what is the option they have given in book bag?
So B, C, and D.
B,
So
C
all the
and D.
three options B, C,
Yeah,
and D.
this is incorrect because we can write lambda B means, but lambda should not be both at a time. Lambda should not be having both the values at a time, either plus, for example, A is equal to B, yes, collinear. A is equal to minus B, collinear, but plus or minus they have given. At a time, two values are given, so that not collinear. Only the correct collinear is first option. Remaining three are wrong. In the same way, you can do that here. I think so. Some here you can change your sign. There it is plus. Option C is wrong. You can see that one. Okay, students, you can practice these questions the same day, like spending half an hour or 1 hour, then it will become very, very easy. Next, we'll start product of two vectors in next class. Okay, product of two vectors in next class. Any doubts, someone? Till here?
No, sir.
Yeah. Right, we'll wind up the class.